It's time once again for Hands-on Arduino. Hands-on Arduino. This is our third session on talking about SPI communication using the Arduino. We're talking again about Arduino to Arduino communication, and we're going to tackle a particular task that can be used in which it's meaningful to use Arduino to Arduino communication. So we're not looking at this as just being some kind of a educational thing. We want it to actually be practical. Not that educational things can't be practical, but we're looking at, in this case, something called a teleoperator. And so the overall task is to control a pair of RC servos at a distance using a joystick. So I have here a little setup that involves RC servos, and we're going to try to control them. Let me just show you a little bit of how the hardware is set up. I want to show you a few features of this whole setup. First of all, we have these shields from Arduino that allow you to easily connect using screw terminals, wires. And the advantage of these is that they are very secure. Usually, if you just poke them into these holes, they pop out really easily. So that's kind of a pain. So by having them attached this way, where for them to pull out, they have to pull out in a perpendicular form from the way the pins are inserted. So they're very secure in there. So that's very nice. These two weren't quite long enough to be able to do that, but that's all right. I also have this joystick, potentiometer joystick, that is used, and I'm just using a ribbon cable to attach it to the shield. This is just a little doodad I rigged together. So I have these two small servos. These are small enough to be driven by the Arduino directly. And I basically just took a paper clip, attached it to the servo here. Poked it through the hole, and then I just wrapped it around the pin cap. And I did the same with this one as well. And so you can see this is just a piece of cardboard that I've attached it to. This is just to give you an idea of connecting two servos for some purpose, like an XY type of control. This is the setup. So before getting into the teleoperator, let's just see how the operator works. So we've seen how the rig is set up. We have the joystick attached to the Arduino through the screw shield. Then we have also, this is our subtask. We're basically going to control a pair of RC servos using a joystick. Okay, so the default pulse width modulation connections for the motor shield, so if we were to use a motor shield to drive this, those use pins 9 and 10, the digital pins 9 and 10. However, pin 10 is used by SPI as the slave select line. So that's not a good choice for so there's a conflict between doing SPI communications and using that motor shield. So we move the pulse width modulation connections to pins 5 and 6 instead and abandon the motor shield. So in this case, the fact that we're using motors that can be driven directly by the Arduino is really a help in this case. It doesn't require that much power to drive these servos, but if we were to require larger motors, that would definitely be an issue. We would need some kind of a servo driver that could allow us to use some other pins besides those used by SPI communication. So that's an issue. So here's our setup. This is a kind of a schematic diagram. Here's a wiring diagram of the setup. So basically, the joystick has two rotary potentiometers in parallel. I'm sorry, in 90 degrees apart. So this is our joystick. So I can move in either what's called the vertical or the horizontal directions. Of course, that doesn't make sense when it's positioned this way exactly. It would be more make sense to put it vertical this way. But anyway, so we have 2 degrees of freedom. And so there are potentiometers at 90-degree angles with respect to each other. And so we can move both potentiometers simultaneously depending on the motion of the joystick. So, but it's basically just a pair of potentiometers. Okay, so that's important. The second thing that we have are the servo motors, and the servo motors have their connections to the Arduino, and so this is how they are wired up. So this is what we need in order to get the thing actually to function. And so notice we're using one Arduino here. Okay, here is the basic control code. It's just fairly straightforward. Okay, so we're going to use the servo library. Servo, and so I have 2 servos, the horizontal and the vertical, since we kind of have a joystick that has a vertical and horizontal motion component. And so we're going to first attach the servo to pin 5. Okay, so the servo H, that's the horizontal, we're going to attach to pin 5. Okay, so that's the first port. And then the second motor, we're going to attach the vertical, we're going to attach to pin 6. And we're going to write a 0, which means it's going to 0 the position. It's going to start off at both servos at 0 position. And so that's where we're going to start. And then in our loop program, we're going to, so here I did a serial begin. Actually, I didn't need to do a serial begin because I'm not actually using any serial data. But anyway, then I set my horizontal value. I'm going to read analog. So my 2 potentiometers are attached to analog channel 0, analog channel 1. And so the horizontal is attached to analog channel 1, the vertical is attached to analog channel 0. And so then the horizontal servo, we can tell the servo to turn to a certain angle according to this map. So notice that this reads the H val, the horizontal value that we want it to be at. So that's the so these 2 values are the desired values that we want the servo to move to. And so we're going to take those values and map them. So these values, these analog values, are basically give us an analog voltage from 0 to 5 volts, which translates when you read it in to a digital or integer value from 0 to 1024. And so we can write it this way. So 0 to 1023 actually is what we get. And so the H value is going to be a value from 0 to 1023, and we want that to translate into angles between 20 degrees and 160 degrees. Now these servos, most servos, only have a range of 180 degrees maximum, but many of them get kind of flaky when you're within 20 degrees of that end, of either end. They can get sticky and stuff like that. So generally speaking, in general, a servo motor is generally only usable between 20 and 160 degrees. So really, it's altogether it's 140 degrees, not 180 degrees that it's usable. But at least it's more than 90 degrees, so that's good. So this is going to translate that. This map command is going to translate that horizontal value into a value between 20 degrees and 160 degrees. And that is actually what gets sent to the horizontal servo and the vertical servo. So we're reading a value from the joystick and we're setting the servo accordingly. And that's all that happens in the loop. Okay, so it actually happens fairly fast. So let's take a look at the video and see how what's going on with it. Now I'm running the sketch, and I'm going to take this joystick and I'm going to move it. Actually, I think I have it oriented wrong. So if I move it this direction, it moves one servo. If I move it 90 degrees, that gives me the other servo, and I can move both servos simultaneously. And I get some kind of funky motion. I didn't design this to do any specific mechanical purpose, but I can make it go like in a circle kind of thing by adjusting the joystick. So this is what the project is intended to do. Okay, so now we're going to do this where the joystick and the servos are separated by a long distance, and instead of using one Arduino to do this, we're going to use two Arduinos. We now come to examine the teleoperator, the real teleoperator. In this case, the teleoperator has this schematic connection. So over here we have our potentiometers that we're working with connected to this Arduino. This Arduino is connected through these data lines to the other Arduino that is connected to these servos. So this is a schematic diagram. Here's a wiring diagram of the same thing. So we have these potentiometers over here. So actually this is the joystick. The joystick has two potentiometers connected to it. Then we have the 4 lines connected up to this, between these Arduinos, and then the servos are connected. So that is physically how things are connected. Let's move on and look at the code. So for master, our setup program is basically the same setup program we had before. The only thing I've changed is I've given it a slightly faster clock rate so that this thing can move basically, well, fast. So 4 megahertz versus 16 megahertz. So it's quite a bit faster. Certainly fast enough for our applications. In our loop program, we have all of this stuff going on. So I have 2 integer values, one for the horizontal value, one for the vertical value. These are the values that are obtained from the potentiometer. I also have the values that I'm going to transfer from one Arduino to the other, which are byte values. So in this process then, I do a digital write to the slave select in order to pull that value low. Then I read both the horizontal value and the vertical values of analog channels 0 and 1. And in the process, I convert them from values ranging between 0 and 1023 to values between 20 and 160. And then I convert these values to bytes. I take these values then, I first transfer the horizontal, I take a little tiny delay, and then I transfer the vertical. And then I let the slave select line go high. And so that's the process. And it just keeps doing that. And so it just continually does that. Notice that I'm not writing anything to the serial monitor, and so I don't have to use serial. I don't actually even have to be connected to the Arduino using the USB while this is running. I can run off an external power source. So this is the master code. It's very simple, very straightforward. So basically the potentiometers are connected up to the master. The values that the potentiometer receives are then transmitted to the slave, to which the servos are connected. So for the slave code, it's a little bit more complicated. So notice I have to include not only SPI but also servo. Notice I didn't have to do servo for the master because the servos were connected to the master. I have a Boolean for data ready. That is, instead of process it like the other, I actually just say data ready. That makes more sense to me. And then here's my value received. The servo I defined 2 servos, one for the horizontal, one for the vertical. And then I have these horizontal value and vertical values. I initialize them to be 0. And then this is a counter. So if you notice in the master, I sent 2 bytes at a time. A horizontal byte, then vertical byte. So I need a counter to keep track of which byte I'm working with. In my setup routine, I have this. So this is pretty much what we've seen before. All of these 3 are what we have seen before. The only difference is that instead of calling the variable process it, I now call it data ready. And then I initialize my counter to be 0. That's the byte counter. And so when the value is 0, I'm going to be transmitting the horizontal value. When the value is 1, I'm going to be when it's 0, I'm going to be receiving the horizontal value. When it's 1, I'm going to be receiving the vertical value. I attach my servos and I initialize them to have values of 0. Okay, so that's my setup routine. All of this I have seen in previous sketches. My interrupt service routine, again, is very similar to what we had before. I put SPDR, the SPI data register, into this variable sval received, which is a global volatile. And one of the things I'm concerned about is if garbage, for some reason, gets transmitted. And it happens. You've seen, for example, before when you have the serial monitor open, every now and then a glitch happens and you get some weird character just randomly gets transmitted. So I don't want my servos to be responding to some random value like that is clearly erroneous. So I check for invalid transmission. So in this case, I noticed that in my master, I sent a byte that was a value between 20 and 160. And so if my value is outside that range, I'm just going to set it to 0. Okay, so that simplifies things. And since the value was received, data is ready. Okay, so that is set. In my loop, I'm only going to do something if the data is ready. If the data is not ready, it's just going to sit there and keep looping. If the data is ready, first thing I check is to see if the counter is 0. If the counter is 0, that means I have transmitted the horizontal value. So sval received goes into the horizontal value. Otherwise, it goes into the vertical value. Okay, so it's going to go into one or the other. So I then write both the horizontal value and the vertical value because I don't know which one is changed. One of them is changed. I don't know which one is changed. One of them is the new value. So I'm just going to go ahead and write both. Notice that if, for example, vval has not changed, then writing this value to the servo is not going to do anything to the servo. So in this way, I don't have to specifically keep track of which one was changed. This will automatically do that, and it doesn't cost us very much. And then I change the counter value from either 0 to 1 or 1 to 0 using this command, and then I reset my data ready so that it's false. So this is my loop, and basically it's all the pieces that we've seen before. Now it's all put together, and so we have the code to do all this. Let's see if it works. The system is now running. The motors are not moving because the joystick is not being manipulated. Over here we have the servo system connected to this Arduino. This Arduino is powered by a 9-volt power supply. This dividing line represents that there is a distance between what's happening here and what's happening here. So these are connected by these Cat6 cables that are outside of the picture. And so the joystick is connected to this Arduino, and this Arduino then is connected to the other Arduino through the Cat6 cable. So the communication that's taking place is taking place through the SPI. So as I manipulate this joystick, I get the same kind of motions I was getting before. when I was able to control it directly without using the SPI communication, using one Arduino. So now we're using two Arduinos, and thus we have demonstrated that this can be controlled using SPI communications. Yes, it works. Great. Well, thanks for joining me on this little adventure with SPI communication and controlling a teleoperator, a joystick remotely controlling by SPI communication, a pair of servos. Thanks for watching.